Hello. We are back. 7.5. Now we are going to add and subtract our rationals. So last lesson we multiplied and divided our rationals. Pretty easy, just factoring first, listing those excluded values, multiplying straight across, canceling out whatever we can cancel out. Remember, instead of dividing, you can multiply by the reciprocal, etc., etc. Well, now we're going to add and subtract. And so very similarly with multiplying and dividing, we're first going to just review how do we add and subtract fractions. Because remember, a rational function is like a fraction. It's a polynomial divided by another polynomial. So remember, in order to add and subtract fractions, we have to have a common denominator. Once we find that common denominator, then we can just add or subtract the numerators and keep that common denominator at the bottom. If you don't use the least common denominator, we just want to make sure at the very end that we need to simplify as much as we can. When it comes to numbers, sometimes we don't always go with the least common denominator, but when we get to factors, we will almost always use that least common denominator. So like I said, let's start off with some numbers. So we have 3/7 minus 6/5. So obviously they do not have the same denominator, so we need to find that common denominator. So what we can do is we can use the denominators of 7 and 5 and multiply them together to get that common denominator. That's always one way to do it. And in this case, it will be that least common denominator as well because 7 and 5 do not have any factors in common. So what we'll have to do is multiply this left fraction by, my pen's not working. So what we'll have to do is multiply the left fraction by 5/5, and then we'll have to multiply the right fraction by 7/7. And so in doing that, we're going to get 15/35 minus 42/35. And so now that they have the same denominator, it will stay the same. And we just subtract our numerators. 15 minus 42 is a negative 27. This fraction cannot be simplified because we did use the least common denominator. And so this is our final answer. Okay, let's try it one more time. This time we have 5/12 plus 1/18. So with 12 and 18, obviously, again, they're not the same. You can multiply 12 and 18 together to get a common denominator, but it won't be the least common denominator. 12 and 18 both have some similar factors, one of which is 6. But 6 isn't going to be the least common denominator. But I know what I can do is I can get 36 as a common denominator because I know that if I multiply 18 by 2 and 12 by 3, then I will get 36 both times. So this is going to get multiplied by 2 out of 2, or 2/2. This is going to get multiplied by 3/3. And so then again, I know my common denominator is 36. 3 times 5 is 15. This time we're adding our fractions. 2 times 1 is 2 over that 36. And so again, common denominator stays the same. Numerators just get added together. 17/36 cannot be simplified. So then that is our final answer. So now let's try to do it with factors, right? With some expressions. So we'll start off pretty easy with the first one. Notice that they do have the same denominator. So there's no need for us to find a common denominator because they already have one. So what we can do now is simply rewrite this as one fraction. And so this is really 3 minus 3x minus 4 over that x squared. Be careful whenever you're subtracting an expression. I'm not just subtracting the 3x. So if I would not have put the parentheses there, your answer probably would have been wrong. Remember, we have to distribute that negative. Okay, so really this is now 3 minus 3x plus 4 over x squared, which is going to be a negative 3x plus 7 over x squared. And you can rewrite that as 7 minus 3x if you want. Doesn't really matter the order. And then just like multiplying and dividing, we do want to list any excluded values. I know it doesn't say it in the directions here, but we are looking at our denominator, and our denominator has always been x squared. So what is going to make that 0 is x cannot be 0. So we have, like I said, you could rewrite it like this if you want it. You don't have to, but this is our final answer. Okay, now we're going to try it where they don't just have the same denominator. So this is going to be more of like what you'll see. So we have x plus 2 over 2 times 2x minus 2 minus negative 2x minus 1 over x squared minus 4x plus 3. Well, the first thing that I want to do is factor those denominators so I know exactly what I'm working with, because if they had the same factors, then that's going to be like part of the common denominator, if you will. So what I'll do is I'll rewrite this denominator as 2 times x minus 1. And then I'll rewrite this denominator. I need to factor it. Factors of 3 that add up to negative 4. That's going to be x minus 3 and x minus 1. So what do these two denominators have in common? They both have an x minus 1. The one on the right has a 2. The one on the left does not. So that means on the left, we need to multiply by 2 over 2. On the left, it doesn't have the x minus 3 that the right-hand side does. So that means on the left-hand side, we need to multiply by x minus 3. Okay? So now I do have a common denominator, and it is 2 times x minus 1 times x minus 3. And you know that it doesn't matter the order that you write those factors in because they're all being multiplied to one another. And so what I want to do now is rewrite my numerators of both sides of those fractions. So this will be my left fraction. I'm minusing, and then the second fraction, 2x minus 1, x minus 3. Okay, so the left-hand side, I was taking that x plus 2 and multiplying it with x minus 3. What I'm going to go ahead and do is I'm actually going to FOIL those together, and you'll see why. So x minus 3 times x minus 2 is going to give me x squared. That's going to be minus x and then a minus 6. And then on the right-hand side, that negative 2x minus 1 just got multiplied by 2. So that's pretty easy. I can just distribute that 2, and I get a negative 4x minus 2. Now that the denominators are the same, all I need to do is combine the numerators. Again, be careful here. You are subtracting this second fraction. So that means my quote-unquote answer is going to have this same common denominator, and it's going to be the x squared minus x minus 6 plus the 4x plus the 2, because I'm minusing a negative, right? So if I can combine like terms, I'm going to get x squared. That's going to give me a plus 3x, and then that's going to give me a minus 4 over my 2 times x minus 1 and x minus 3. Okay. What I would probably do right now is list my excluded values, so I know that x cannot be 1 and it cannot be 3. But I'm also going to factor out this numerator again, so because it is factorable. Factors of negative 4 that add up to positive 3, that's going to be an x plus 4 and an x minus 1 over that 2 times x minus 1, x minus 3. And remember, we said simplify when we can. I can simplify here because I see that this x minus 1 factor cancels out at the top and the bottom. So now my final answer is just x plus 4 over 2 times x minus 3. Just like multiplying and dividing, you do not have to expand your numerator or your denominator unless you just want to. So if you wanted to rewrite this as x plus 4 over 2x minus 6, that's totally fine, but you definitely do not have to take that extra step. Okay? All right, let's try it again. So again, with C, we have these two fractions. They do not have the same denominator, so we need to find that common denominator. In order to do that, factoring is going to make our life so much easier. So I need to factor the denominator of the first one. So factors of negative 12 that add up to negative 1, that's going to be negative 4 and positive 3. My a value is 1, so I can go ahead and just rewrite that as x minus 4, x plus 3. And then in the second fraction, I can factor that because there's a GCF of 12. So pulling out that 12, I get x minus 4. And so now I want to compare the two denominators. I notice that they both have that x minus 4 in common. And so I need to multiply by what the other one doesn't have, or does have if you want to look at it that way. So what I'm saying here is on the right-hand side, I see an x plus 3, but it's not on the left-hand side. So the left-hand side needs to get multiplied by x plus 3. And on the right-hand side, I have a 12, which is not on the left-hand side. So the left-hand side needs to get multiplied by 12 over 12. Okay, so then that means my common denominator is 12 times x minus 4 times x plus 3. I need to rewrite my numerators, so I'm going to go ahead and multiply this out. This is going to be 12 times x over that 12 times x minus 4, x plus 3. This time I'm adding the fractions, and this over here I get the 5x plus 15. I'm just distributing that 5 over, again, the 12 times x minus 4x plus 3. And so this time, because we're just adding, I don't have to like distribute a negative or anything like that, so I can go ahead and just combine. So that's going to give me a 17x plus 15 over 12 times x minus 4x plus 3. I want to make sure I can't simplify or factor out my numerator, which I cannot. So because I can't factor that, that means nothing is going to cancel out with my denominator. So this is my final answer, and my excluded values are 4 and negative 3. Okay. Alrighty, let's go pink. So here we are again. Gotta look at the denominators, factor it out. The denominator on the left cannot be factored. The denominator on the right can be, because there's a GCF of 3x, leaving me with x plus 1. So that means really on the right-hand side, 9x squared actually can be factored in a way, because I noticed that 9 is a perfect square and x squared is a perfect square. So really this is 3x times 3x. And the reason why it kind of caught my eye is because I saw this 3x here. So now what I need to do is I need to multiply the right-hand side by another 3x. And then I need to multiply the left-hand side by that x plus 1. Okay, so now I have a numerator of 7x plus 7 over the 9x squared, really, times x plus 1, plus, then I have a 3x squared over the 9x squared times x plus 1. And so I want to combine my numerators now that the common denominators are there. So this is going to be 3x squared plus 7x plus 7 over 9x squared times x plus 1. I want to check to see if I can factor that numerator to see if anything will cancel out, but I can't, because really I'm looking for factors of 21 that add up to 7, and that's not possible. So this is my final answer, and my excluded values are 0 and negative 1. Okay. And then the last one in this section. So as always, we're looking at our denominators. Our denominators can be factored, so that's fine. However, I'm noticing that they're very, 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 very similar. They're definitely not the same, but they're similar. So I want to look at, the first one is how we normally see factors, x plus or minus a number. The second one is kind of inverted, right? So let's talk about what 4 minus x really is. If I rewrite that, that's negative x plus 4. If I rewrite that, I could write that as negative x minus 4. And what do you know? This is the same. So if I rewrite this denominator as negative x minus 4, and I'm trying to get a common denominator, then that means the only thing that's missing on the left is a negative. So I'm going to multiply by negative over negative, or negative 1 over negative 1. And then that'll get me a negative x squared minus x plus 27 over negative x minus 4 plus same thing, x squared minus 8x plus 9 over that negative x minus 4. Now what I can do is I can combine those numerators because the denominators are the same. So I have negative x squared and x squared cancels out. Negative x and negative 8x is negative 9x. 27 plus 9 is 36 over negative x minus 4. Can I factor the numerator? Yes, I can, because this time there is a GCF. So if I take out the GCF of 9, or negative 9 really, negative 9 is going to leave me with x minus 4. And so what do you know? Those cancel out. So really my final answer is negative 9 divided by negative 1, which is just 9. My excluded value is technically x cannot be 4. However, my final answer doesn't have an x in it. So no matter what I plug in for x, I'm always going to get 9, even if I plug in 4, because there's not an x in my answer to affect it. Now, this is kind of the only case where it's okay if you leave off that excluded value, but it's definitely not wrong if you include it in the answer. So what I would suggest is keeping that same pattern of just getting in the habit of writing those excluded values, even if you come across some kind of odd answer like 9. That's not going to happen very, very often. So might as well, like I said, just get in the habit of writing those excluded values. All right, and so that's really it for your lesson. This is adding and subtracting rational functions. However, we do want to take it a step further. You are in an honors course. Most of you are going to be going to pre-cal either in the summer or next year. And so we do want to kind of enrich you with some complex fractions. So complex fractions are combining the adding and subtracting and the multiplying and the dividing aspect of it. So we'll try a couple. And they look very overwhelming, but they're really not so bad when you really dive into them. So focus on just your numerator, and then focus on just your denominator, and then focus on the whole problem. Excuse me. Well, if I focus on just the numerator, I see two fractions being subtracted. So I need to find a common denominator. Well, this one's easy because it's just numbers. What's the common denominator between 6 and 3? 6. So this second fraction needs to get multiplied by 2 over 2, which means I now have x minus 6 minus 2x over 6. So that's going to give me negative x over 6. So my numerator is done. Negative x over 6. Now I look at my denominator. So my denominator, again, is subtracting two fractions. I look at the denominators of those fractions. They're not the same. What's the common denominator, though? 10. So this left fraction needs to get multiplied by 2 over 2, which means I have 2x over 10 minus 7 over 10, which gives me 2x minus 7 over 10. So I've worked the top, I've worked the bottom. Now let's work the whole problem. So I'm going to rewrite this as negative x over 6 divided by 2x minus 7 over 10. Remember, when we divide fractions, we can multiply by the reciprocal. So now I can really rewrite this as negative x over 6 times 10 over 2x minus 7. At this point, I can see if anything can simplify or cancel. I'm looking at my diagonals. Negative x and 2x minus 7, nothing can cancel or simplify. But the 10 divided by the 6, they're both divisible by 2. So this can actually turn into a 5, and this can turn into a 3. And so now I'm going to get a negative 5x in the numerator, and then 3 times that 2x minus 7. And that is my final answer. I still want to list any excluded values. In the original problem, everything in the denominator was just a number, so excluded values aren't needed there. However, in my final answer, I clearly see a variable of x, so that means x cannot be 7/2. So this is my final answer. And again, if you want to rewrite this as negative 5x over 6x minus 21, you are more than welcome to do that, but you don't have to take that extra step. See, it's not so terrible, especially when you have those kind of quote unquote easier fractions to work with. Okay, but now let's look at something like b. So again, we have the numerator, which are two fractions being subtracted. This time in our denominator is just a variable. So let's tackle the numerator first. I want to find a common denominator because I'm subtracting. Well, clearly I can see that x plus h is going to be the common denominator. X times x plus h. I can't just say, oh, I'm going to add h and I'm going to add h, right? To find a common denominator, or to get a common denominator, notice we always multiply by something. So this means this right-hand side needs to get multiplied by x plus h, and the left-hand side needs to get multiplied by x. So that means the common denominator is x times x plus h. So in rewriting this numerator, I have x over x times x plus h minus x plus h over x times x plus h. Now I can combine those fractions. Be careful though when you're subtracting. I'm subtracting this whole numerator. So really, to make my life easier, what I'm going to do is I'm going to change this to add and then subtract. You know, like the whole it's not keep, change, or whatever. Or maybe it is. I don't know what y'all call it. But instead of subtracting something, I'm just adding by the opposites. Or adding the opposites. So now when I combine my numerators, I have just negative h over x times x plus h. So now this is my numerator, and all of that is being divided by h. So I'm going to rewrite this as negative h over x times x plus h divided by h. And you know that h is really over 1. Remember, division problems can get rewritten as multiplications. So negative h over x times x plus h multiplied by 1 over h. And so now you can see, something cancels out here. I'm left with a negative 1 over x times x plus h. Still want to write out those exclusions. This time we have two variables, so x cannot be 0 and h cannot be 0 either. Not because of here, but because of here. Okay? All right. And one more to do. And this one looks very, very overwhelming. But again, it's not going to be so bad once you really dive into it. So I have 2x over x minus 6 minus x plus 1 over x minus 3. So I'm only focusing on my numerator first. I have to find a common denominator because I'm subtracting those fractions. My denominators are already factored for me, so my common denominator is x minus 6 times x minus 3. So this side gets multiplied by x minus 3. This side gets multiplied by x minus 6. So I'm going to rewrite that as, I'm going to go ahead and distribute. I have 2x squared minus 6x over x minus 3, x minus 6, minus, if I FOIL this out, that's going to give me x squared minus 6x plus 1x is a negative 5x, and then minus 6 over x minus 3, x minus 6. And then what I would do there is I would simplify my numerator. So then I have that common denominator, x minus 3, x minus 6. Remember, I'm subtracting this whole entire thing. So instead of distributing that negative, I can really just add and then take all the opposites. So my new numerator is going to be 2x squared minus x squared is just x squared. Negative 6x plus 5x is negative x. And then I have my plus 6. And then I'm going to go ahead and factor that, because what are factors of 6 that add up to negative 1? And that would be a negative 3 and a positive 2. So x minus 3. I don't know why it does that. X minus 3 and then x plus 2 over x minus 3, x minus 6. I don't want to cancel anything out just yet. Just give it a little while. But let's focus on the bottom now. Okay, so again, I want to find that common denominator. I need to factor this. What are factors of 18 that add up to -9? So that's going to be -6 and -3. And good news for us, that is our common denominator in the numerator, but that means we only need to multiply this by x minus 3. Oops. So rewriting that, I now have x minus 3 times x minus 2 is x squared minus 5x plus 6 over x minus 3, x plus 6, minus, I didn't have to multiply the second thing by anything, so that's just 2x plus 1 over x, oops, I did plus 6 there, my bad, minus 6, x minus 3, x minus 6. I can simplify that now, again, so that's really x squared minus 7x plus 5 over x minus 3, x minus 6. So just in looking at these two denominators, the denominator of the numerator and the denominator of the denominator, we can clearly see that our excluded values are going to be 3 and 6. But what I want to do right now is I want to rewrite this problem. Notice I cannot factor this top. There are no factors of 5 that add up to -7. So that's why I didn't factor it out. It's because it's not factorable. So let's put it all together. So I had this x minus 3 times x plus 2 over x minus 3, x minus 6. It was being divided by x squared minus 7x plus 5 over x minus 3, x minus 6. Oops. But instead of dividing fractions, we can multiply by the reciprocal. So now I'm going to have x minus 3, x plus 2 over x minus 3, x minus 6 times x minus 3, x minus 6 over x squared minus 7x plus 5. Now I can cancel. Boom, 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 boom. So I'm left with x minus 3, x plus 2 over x squared minus 7x plus 5. So remember, I cannot factor this denominator. If I put in the quadratic formula, I'm going to get imaginary numbers. So that doesn't make sense for me to list them in my excluded values. So my excluded values are still only 3 and 6, and this is your final answer. All right, so like I said, this second part, you still need to know, but it is definitely more of an extension. But the first part is really your nuts and bolts. That is your just adding and subtracting rationals. See ya!